Hello everyone, let's discuss about statically determinate and indeterminate truss. First, let us consider this simple example. This is a truss, the most basic system, and we have two support. One is hinged and one is roller. At the hinged, we will have two reactions, and at the roller support, we will have one reaction. This much we know. Now, there are three joints in this truss, and at each joint we can write two equations of equilibrium: summation of forces along x equal to 0 and summation of forces along y equal to 0. Now, what are the total unknown in this system? The three reactions are unknown force, then the member forces are unknown. There are three members in this truss system, and there are three unknown member force. So total unknown will be the member force plus the reactions, and these unknown will have to be solved by using the equations of static equilibrium. We will see if we can solve or not. We can write two equations at each joint. That means for three joint we can write 6 equations. We have 6 unknown, we have 6 equations. That means we can solve the unknowns with the equations of static equilibrium only. That means this is a statically determinate system. So this is how we denote. M is the number of members, 3 in this case. R is the number of reaction, 3 in this case. J is the number of joint in the truss, 3 in this case. So the total unknown will be member force plus reaction, and equations of equilibrium will be 2 times the number of joint. So it will be statically indeterminate is M plus R is greater than 2 times of J. And if M plus R is exactly equal to 2 times of J, this is going to be statically determinate. Now the degree of static indeterminacy will be M plus R minus 2 times of J. Now there are two types of indeterminacy. One is internal indeterminacy and one is external indeterminacy. If we have a truss system where there are extra members then required for the balanced or stable structural system, then we have an internal indeterminacy because we have an extra member then required. Now if we have extra support reactions then required for the structure to be stable, then we will have an external indeterminacy. So the indeterminacy arising from external support condition is external indeterminacy, and the indeterminacy arising from internal members is internal indeterminacy. Now going to these examples, this is a truss. We have to find out if it is statically determinate or not. If not, what is the degree of indeterminacy? So first we will see how many unknown forces we have. We have 3 reactions at the hinged and roller support, and we will have how many members? We have 18 members. So 18 plus 3, 21 is the total unknown force. And to solve that, how many equations of static equilibrium we can have? 2 times the number of joints. So we see that M plus R, 18 plus 3 is the unknown force, and we have 10 joint, 2 equations at each joint, so 20 equations we will have. So 21 minus 20 is equal to 1. That means this is a statically indeterminate structure, and the degree of static indeterminacy is 1. Then this one, another example, we have roller and hinge support. So we will have 3 reaction, we have 11 members. So 11 plus 3, 14 will be the total unknown force. We have 7 joint, 7 into 2, that is we can write 14 equations of equilibrium. Now 14 minus 14 is equal to 0. That means the degree of static indeterminacy is 0. That means unknown force is exactly equal to the number of equations we can write of static equilibrium condition. So that means we can solve the unknown from the equations of static equilibrium only. So this is a statically determinate structure. Then another example, this one you will solve.